For this example, the left-hand side is the difference of the fourth power of the cosine and the fourth power of the sine of the t, all divided by cosine square of the t, where the right-hand side is 1 minus the tangent square of the t. When you look at the two expressions, the left and the right expressions, the left one look more complicated. So that's what we're gonna work on for this problem. So work on the left-hand side expression, which is the power 4 of the cosine t minus the power 4 of the cosine t divided by cosine square t. As you see the power 4 and the power 4, think about the quantity squared minus the quantity squared, that we can use the property that when you have x squared minus y squared, you can factor them as x minus y times x plus y. But this case, if you have the power 4 minus y to the power 4, you can write it as x squared squared minus y squared squared. And then you can factor them as x squared minus y squared times x squared plus y squared. In this case, we can write the power 4 as cosine power 2 squared and sine power 2 squared. And after that, we factor the numerator as cosine square t minus sine square t multiplied by cosine square t plus sine square t, all divided by cosine square t. And then when we look at the product, the group of the sum of the power 2, we can use the Pythagorean identity, which cosine square t plus sine square t equals 1. That means this factor is replaced by the value 1. Now we can write it as cosine square t minus sine square t divided by cosine square of the t. Now, the right-hand side has no denominator. It has just two different terms. We're going to split one whole fraction here into two separate terms to get cosine square t divided by the common factor, which is cosine square t, minus sine square t divided by cosine square t. As we see, the cosine square over cosine square equals 1. And another identity that we can bring into the expression is the sine t, the sine t over cosine t is the same as the tangent of the t. Then we're going to replace this expression by tangent squared. And then finish off the expression by the first term is the same as 1. The second term is the same as tangent square t. And now we have the expression the same as the right-hand side expression. And then we are done proving these identities.